Good afternoon, student. Welcome back to Mr. Chen's master class for pre-calculus. So today I just want to continue to talk about that proving identity. So this one is section 7.1, the second half, the lecture. Okay, so let's take a look at that. So prove that cosecant of x plus cotangent of x equals sine of x all over 1 minus cosine of x. Okay, so let me just put it out here. Okay, so anytime that you want to prove the identity, so if you don't see anything like Pythagorean identity, you can apply, or any special identity you can apply. So that means you want to rewrite it in terms of sine and cosine for tangent, cotangents, secant and cosecant. Well, for this one, obviously the right hand side, it's the simplest form. So the only thing that we need to verify is the left hand side. So first thing that you want to do, rewrite it. So rewrite this one as 1 over sine of x, cotangent, cosine over sine. And then basically this one, we just want to combine the numerator together. So 1 plus cosine of x, all over sine of x. And now you might be wondering, well, this one here, we do have sine of x on the top, and then the binomial, 1 minus cosine of x down the bottom. So basically what we can do, we can rationalize this. So a lot of people know how to rationalize the denominator, but this time we need to rationalize the numerator. So we need to multiply by the conjugate of the numerator. Okay, so multiply by 1 minus cosine of x, always the conjugate of the binomial. And then you'll end up with 1 minus cosine square of x over 1 minus cosine of x, the factor, times sine of x. So one thing that we notice by using the Pythagorean identity, so this one is considered sine square of x. So once you reduce it, so this one, it's considered sine of x over the quantity of 1 minus cosine of x. And then it's ditto. Okay, like that. And now, what about for number 2? So number 2, that one looks like it's going to be a little bit hectic. Okay, so let me just snip this one. Okay, let's put it out, put it right here. So again, using the same strategy. So nothing we can do, nothing like any special identity we can apply, such as the Pythagorean or double angle or anything. Well, double angle, we'll talk about that in the next 2 videos. Okay, so this one started off with rewriting. So sine of y over cosine of y. Denominator, 1 minus cosine of y over sine of y. Again, rewrite. And then for the second rational expression, so cosine of y over sine of y, all over 1 minus sine of y over cosine of y. So this one, obviously the right hand side is the simplest form. Okay, so now what can we do with this complex rational expression? Well, the things that we can always multiply the LCD top and the bottom, which is considered cosine of y, sine of y. And this one also, cosine of y, sine of y. Okay, so cosine of y, sine of y. So multiply by the LCD, top and the bottom. And then distribute, so what we can do here, cross cancel. So we got sine square of y, all over cosine of y, sine of y, minus cosine square of y. And then plus this one here, cross cancel, so we do have cosine square of y. All over cosine y, sine y, but minus sine square of y. And now, so you might be wondering, how do we combine this together? So it looks like they're kind of close with the denominator. And now, before we find the LCD here, the LCD for this 2 binomial, so we want to factor this a little bit. So take out the GCF. So we do have cosine of y. So times sine of y minus cosine of y. Sine square of y, just bring it down. Okay, so the other rational expression, cosine square of y, bring it down, and then take out the GCF, greatest common factor. So we do have sine of y times the quantity, cosine of y minus sine of y. So in order to combine them, so we need to make sure that they do have the exact same common denominator. While this one, the binomial, they're pretty similar. Hey, guess what we can do with this? We can actually swap the terms. So take out that -1. So we got negative cosine y times cosine y minus sine of y. So basically what I'm doing here, I'm just switching those two terms. But by the time you switch them, you want to take out the negative sign. Okay, so on top of that, just keep it that way. So compare and contrast. So what do you notice about the least common denominator? So we do have cosine of y minus sine of y for both of them. So the only thing that you need to multiply here is just what? Sine of y. Okay? So multiply the top and the bottom by sine of y. And this one here, so it looks like we're missing the negative. So we need the negative, and also we're missing the cosine. So multiply the top and the bottom by negative cosine of y. Okay, so rewrite it. So sine of y times sine squared of y. So sine of y to the power of 3. Cosine of y times negative cosine of y. So minus or negative cosine of y, quantity to the power of 3. And then it's all over the same common denominator. So negative cosine y, sine y. And then quantity cosine of y minus sine y. So now what do you notice about this one here? Well, this one is just the difference of 2 cubed. So difference of 2 cubed, if you try to expand it, so sine of y minus cosine of y times the quantity of sine squared of y plus sine y, cosine y, and then plus cosine squared of y. And then it's all over this whole thing, the least common denominator. And now, what do you notice at this moment? So sine squared of y plus cosine squared of y, that's just 1. And this two term right here, basically they're similar. If you just swap them, it's just -1 after you reduce. So negative over negative, which is what? Positive. And then for this trinomial, so we'll end up with negative times 1 plus, because sine squared of y plus cosine squared of y, that's 1. Plus sine of y, cosine of y. Again, the negative, negative, so both of them got canceled. Positive, positive. And now what happened with the binomial over this monomial? We can split it. So once you split it, you'll end up with 1 over cosine of y, sine of y. And then plus sine of y, cosine of y, over cosine of y, sine of y. This one can be written as secant and cosecant. And then this one right here, reduce, plus 1. Same as what we have on the right hand side. Okay? So this one requires a lot of work, a lot of factoring, a lot of rationalizing. So again, it's all about the algebraic approach to find out things cancel, things that we can combine. Okay, so now what about for number 3? So prove that 1 plus secant of t, quantity to the power of 3, times 1 plus cosine of t, quantity to the power of 3. So that equals secant of t cubed times 1 plus cosine of t, quantity to the power of 6. So this one with the higher power. So how do we come up with the proof for this one? Okay, let's take a look at that. It's not going to be as difficult as number 2. Okay, we'll find out. Okay, so this one, you try to expand it by using the binomial expansion, then that'll be a little bit hectic. Okay, so for those people who might be thinking about that, the binomial expansion is like 1 cubed plus 3 secant of t, and then plus blah blah blah. Please don't do that, okay? Because that would be kind of tedious, because you have to FOIL it, and then there's so many terms that you end up with. Here's what we can do, using that the rule of PEMDAS. So let's say that we do have a measure of an angle. We always want to evaluate what secant of t first. Now, starting from secant of t, let's just rewrite it as cosine. So it's 1 over cosine of t. Okay, like that. Another thing that we notice, 1 over cosine of t plus 1, this one we can actually combine them. We can put them all together. So this one could be considered cosine of t over cosine of t, because that's just 1. And then combine it with 1 over cosine of t. So then that would be considered cosine of t plus 1 all over cosine of t. Then the whole quantity to the power of 3. So again, basically what I'm doing here is just like a rational expression. So I just combine those integer and the rational expression together. And then the power, distribute, top and the bottom. Okay. And now, guess what we can do right here? It's the same binomial with the same power. So base to the power times base to the power. That means we combine the exponents together. So this one turns out to be cosine of t plus 1 to the power of 6 all over cosines of t, quantity to the power of 3. And then what we can do here, we can split it. So this one can be separated like this, 1 over cosine of t power of 3 times cosine, not cotangent. Keep putting that cotangent, excuse me. It's supposed to be cosine right here. Cosine of t plus 1. So basically what I'm doing here, I just want to split it. So 1 over cosine of t, quantity to the power of 3, times cosine of t plus 1, quantity to the power of 6. And then, what do you notice? 1 over cosine of t to the power of 3, it's a secant cube of t. And then cosine of t plus 1, quantity to the power of 6. And then the right hand side, just bring it down. Ditto. Okay, so it's more rigorous proof. Okay, so a lot of people might be thinking about that to expand it. If you try to expand it, it's going to be tedious, it's going to be crazy. There's so many terms involved. If you try to expand this out, this one's going to be 4 terms. This one too, it's also going to be 4 terms. So 4 times 4 terms times 4 terms is going to be like what? It's going to be like 16 terms. So you don't want to deal with that. Okay, so instead of doing like that, so simply combine the integer with the trig expression together, and then from there find a way to separate them. Yeah. So now let's see what else that we have right here. So number 4, if you guys see the pattern, so secant square of quantity, pi over 2 minus x minus tangent square of the same quantity, so of pi over 2 minus x, all over secant of that the same quantity plus tangent of the same quantity. So what do you guys notice? Would that be the difference of 2 square right there? Okay, so let's just put it out. So let's say that we do have, okay, let y equals pi over 2 minus x. But those people might be wondering, well, can I use the cofunction identity? Yes, certainly you can do that. But let's do it later, okay, with the cofunction. Let's keep it that way. So y equals pi over 2 minus x. So we write it, so it's like secant square of y minus tangent square of y. All over secant of y plus tangent of y. Okay, right hand side, that's the simplest form. We don't want to do anything about it. And then this one, factor it, difference of 2 square. Okay, so once you put in to the form the difference of 2 square, what do you notice? Things that we can cancel, top and the bottom. So secant of y, tangent of y. And what's left here is just secant of y minus tangent of y. Again, pi over 2 minus x of secant. So this one basically gives you the same kind of the function as well, cosine. So notice, so secant of pi over 2 minus x, so it's the same as cosecant of x. So basically this one can be written as cosecant of x minus tangent of y, so tangent of pi over 2 minus x, is the same as cotangent of x. Right? And then this one here, just rewrite it in terms of sine and cosine. And then just combine them together. So 1 minus cosine of x over sine of x. And then you want to split it. So 1 minus cosine of x all over 1 times 1 over sine of x. And guess what you come up with this? So 1 minus cosine of x times cosecant of x. Same thing as what we got on the right hand side. Ditto. Okay, so that's number 4. And what about for number 5? Okay, let's take a look at that. Number 5. So prove that cosecant of x to the power of 6 minus cotangent of x to the power of 6. So that equals 1 plus 3 cosecant square of x times cotangent square of x. So what happens once we deal with the high power? Once we deal with the high number of power, what's the best way to verify? Okay, so let's find out. Okay, excuse me for a second.